Hello, Ashley here, and today I'm going to be walking you through an educational video looking at inspiratory muscle warm-up. So what are we going to do today? We're going to look at what benefits this may have, or what it may lack to the sports performer. We're also going to look at the power breathe, which is supposed to be this inspiratory muscle trainer. Will it have an effect? We don't know. We'll look at the articles and various literature and the methods they use to find out if this actually works. Finally, after that, we'll summarise.
Warm-up is needed to increase overall body and muscular temperatures, which increases the blood flow to the active muscles as well as helps to increase the rate of energy production. Contraction and reflection times are also improved with higher muscular temperatures, meaning better performances. But important things to think about are the duration at which you warm up at, because you don't want to cause fatigue, the recovery, as you need adequate rest, intensity at which you warm up, as most arguably the most important, which is specificity of the warm-up, as this is going to prepare the certain muscle groups for optimal performance. This can be done actively as well as passively. So, inspiratory muscles are involved with inspiration and are responsible for the elevation of the ribs and sternum. These are also known as the external intercostal muscles and the diaphragm. The breathing pump muscles are a complex arrangement that are formed as semi-rigid bellows around the lungs. Contractions of the skeletal muscle is known as an active process of inspiration or inhalation. The pressure difference between the intrapleural space and abdominal cavity is created by the diaphragm. If these inspiratory muscles have been trained, it may mean a greater amount of oxygen taken into the blood on its way to the working muscles. According to Roma et al. In 2006, it was also known that the metabolic demand is higher during maximal exercise. Pulmonary musculature requires up to 15% of maximal oxygen uptake, according to Aaron and colleagues in 1992. As well, these muscles are responsible for 14 to 16% of body's cardiac output, which is seen by Harms in 1998. To warm up these inspiratory muscles, what could we use? What devices are out there? Let's have a look.
So, this inspiratory muscle trainer, what does it actually do? And how do we do it? So, we've got the power breathe machine. What we do is we get the participants to expire all their air. And then we get them to inspire, supposedly training the inspiratory muscles. Does this benefit us? We don't know. We'll use the literature to find out.
To start off, we're going to look at a study done by Johnson et al. In 2014, where this study examined the effects of an active cycling warm-up with and without the addition of an inspiratory muscle warm-up on a 10-kilometer cycling time trial performance. So for this, there was 10 road-trained cyclists performing in this study, where they completed 3 main trials, the first being the control group, which had no previous warm-up. The second trial of a previous cycling-specific warm-up, doing 3 consecutive 5-minute bouts at 70%, 80% and 90% of their gas exchange threshold. The third and final trial being the same as the second trial, but with the addition of an inspiratory muscle warm-up using the power breathe, doing 2 sets of 30 breaths against a pressure load of 40% of their maximal inspiratory pressure, or MIP as it's more commonly known. The warm-up was followed by a 2-minute rest, and then the time trial was then performed. This can more accurately be seen by the diagram. Now we're going to look at Tong and Fu from 2006. They looked at the effects of inspiratory muscle warm-up on the maximum dynamic inspiratory muscle function and the maximum repetitions of a 20-meter shuttle run. This was done by 10 recreationally active and healthy men who were recruited to perform identical inspiratory muscle function tests and exercise in 3 different trials in a random order. This was done by a self-paced warm-up on a treadmill, then followed by the self-desired stretch, and then followed by a self-paced ground run. After all these, the yo-yo intermittent recovery test was completed. So, the first trial being with the inspiratory muscle warm-up. The second and third trial, known as the placebo and experimental trials, had the inspiratory muscle warm-up added in to a point seen on the diagram. The placebo group, the inspiratory muscle warm-up, was that of 15% of their MIP, and experimental group saw 40% of the MIP. So after looking at both these studies and their respective methods, can you decide which one will show more benefit or significant results? I can't, so let's have a look at the results. Well, let's have a look. Johnson et al. In 2014 time trial saw an increase over the first 4 to 5 kilometers in their power output, but therefore after returned to similar between the trials. They also show an increase of 8% in MIP after the inspiratory muscle warm-up compared to those of the control group and the cycling group, but show reduction back to baseline after the time trial. Ventilatory response saw no difference, although breathing frequency was higher during warm-up periods of the cycling and cycling plus inspiratory muscle warm-up trials. Perceptual response throughout the warm-up and time trial periods did not differ, although RP and dysphonia through the warm-up and time trial periods were higher in these exact same groups. Therefore, these results show no mass effect of performance after the use of inspiratory muscle warm-up. Now moving on to Tongan Food's results. They show different to these found in Johnson et al. In 2014, where found that adding an inspiratory muscle warm-up to the whole body warm-up improved yo-yo test running performance by 90%, and also found that inspiratory muscle warm-up was significantly greater in maximum dynamic inspiratory muscle warm-up function when comparing these to the control and placebo trials. This is in agreement with this seen in Volitas et al. In 1999, where they've shown an increase of 8.5 and 11.2 in their static maximum inspiratory pressure. There is also seen a slope of the linear relationship of the increase in rating of perceived breathlessness for every fourth exercise interval as it was reduced. How do we see differences in results? Well, Tongan Fu have a standardized body warm-up, which is not actually standardized, as participants were able to run on a self-paced warm-up. As well, they didn't have a control group where there was no warm-up done in order to compare to that done of the inspiratory muscle warm-up, including the warm-up. As well, the inspiratory muscle warm-up was integrated into their whole body warm-up, which meant more resting time and recovery period after their exercise meant performance times might be greater. We can now look at another angle of this topic of inspiratory muscle warm-up and see if other studies may agree or disagree with studies previously mentioned. Next, we're going to be looking at Lomax and colleagues, looking at inspiratory muscle warm-up and inspiratory muscle training, separate and combined effects on intermittent running to exhaustion, as well as looking at Arlen and colleagues. They look at the effect of inspiratory muscle warm-up on submaximal rowing performance. So, looking at Lomax and colleagues, they examined 12 county standard and semi-professional male footballers. The protocol used consisted of 4 trials, with trial 1 and 2 being completed in a 4-week training period, completing one set of 30 breaths twice daily in either the experimental group of 50% MIP or the control group of 15% MIP. A further 2 trials were completed after the 4 weeks, where the warm-up was preceded by 2 sets of 30 breaths at 40 MIP. Pre-training MIP and distance covered increased similarly between the groups after the warm-up, but in both the control and experimental groups, running distance was the lowest in the absence of inspiratory muscle warm-up. Now looking at RN et al., who had 10 competitive male rowers between the ages of 19 and 27 who took part. A sub-maximal intensity rowing test was carried out twice, with the standard rowing warm-up as test 1 and the standard rowing warm-up and specific inspiratory muscle warm-up as test 2. During the test, the 2 experimental tests looked at distance, duration, heart rate, breathing frequency, ventilation, peak oxygen consumption, and blood lactate concentration. The main finding of this study was that the inspiratory muscle warm-up at 40% of MIP before submaximal rowing does not significantly enhance performance in well-trained male rowers. However, it may have some small effect on physiological parameters, as well as inspiratory muscle warm-up caused statistically higher breathing frequency between tests 1 and 2. So, to conclude, do we agree with the findings of these articles? Do we feel they may have design flaws, or we can confidently say that inspiratory muscle warm-up is an effective way to enhance performance levels? Personally, I don't think so, but that's only an opinion. Articles say that it does, but many of them have design flaws. But there's not a lot of evidence backing that non-beneficial campaign. I feel it may be down to personal anatomy and function.